Hello friends, today's question. A rod of length L at room temperature and uniform area of cross section A is made of a metal having coefficient of linear expansion alpha per degree centigrade. It is observed that an external compressive force F applied on each of its ends prevents any change in the length of the rod when its temperature rises by delta T Kelvin. So Young's modulus of Y of this metal is. So in this case, you can say we have two forces. One will be the compressive force and another will be the internal force that will be, you can say, in the form of a strain, because as the temperature is going to increase. But it is said in the question that the compressive force is applied such that there is no change in the length of the rod. So it means this compressive force is going to balance the strain force that is the strain caused by the internal force. So we are going to equate them and get the answer. So let us find out what will be the thermal expansion without the application of the force. Thermal expansion without the force. Thermal expansion without force. Force means compressive force. So it means in case of no application of external force, the change in length due to the thermal expansion with the increase in temperature is given as delta L, and delta L is equal to alpha multiplied by L and delta T, where L is the original length and delta T is the rise in temperature. You can say if no external compressive force is applied, no external compressive force is applied, the change in length, which is given as delta L due to the thermal expansion, with temperature increase, with temperature increase by delta T, is the formula is delta L is equal to alpha, that is the coefficient of linear expansion, L multiplied by delta T. Okay. Where L is the coefficient of linear expansion, alpha is the coefficient of linear expansion, alpha is coefficient of linear expansion, L is the original length of rod, and the increase in temperature is given as delta L. Now we discuss what happens when the compressive force is applied. So we can say preventing the length change with compressive force. Preventing the length change with compressive force. So it means when the compressive force F is applied, it prevents any change in the length of the rod, or we can say it counteracts the thermal expansion. So we can say when the compressive force F is applied to prevent any change in the length of the rod, that is, it counteracts the thermal expansion. The thermal expansion. So it means this compressive force induces a compressive strain that balances the expansion. So you can say that this compressive force, induces a compressive strain that balances out the expansion. That balances out the expansion, and this expansion is due to temperature rise. Due to temperature rise. So we can say that the strain caused by the force strain caused by this compressive force will be equal to delta L, because the change in length divided by original length, and we can say this will equal to minus F upon Y into A, where F is the compressive force, Y is the Young's modulus, and A is our cross-sectional area, where our F is our compressive force, Y is Young's modulus, and A is cross-sectional area. Now we can equate this compressive strain and our, you can say, the applied. So therefore, equating the strains. Equating the strains. So as in the question itself, it's given that the force exactly prevents any change in the rod's length. We can say that compressive strain should be equal to the magnitude of the thermal strain. So you can say, since the force exactly prevents any change in the length of the rod, any change in the length of the rod. So therefore, the compressive strain compressive strain must be equal to in magnitude to the thermal strain, or we can say that our F upon YA should be equal to alpha into delta T. Okay. So from here we can say F is equal to Y is equal to F divided by A alpha delta T. So this is the Young's modulus of the metal. So you can say this is the Young's modulus of the metal, and the options that are available to us, you can see that option D is the correct option. You can write that option D is correct. So I think I think this is this completes the question. Thank you.